All right, guys. Hey, this is part two to the Machinist Training Program series that I'm posting from earlier today. I did the part one video on a quick overview of what a machinist is, what a machinist does, and what the education requirements are to become a machinist. So it was really a brief overview. Here's part two to that. So what I talked about in the first video, if you hadn't seen it, but I recommend you see it first, is what a machinist is, what the machinist training program entails, where I took mine at, which was Santa Fe Springs, California, and I went over the things in this particular course catalog, which is current for the year of 2020. And again, I say refer to the first video to cover those basics. We're going to get a little bit more in depth in the part two video. First, I'm going to pick up where I left off, which is basically kind of like around here, which talks about the cost of the course. The course is scheduled for 7 months. There's registration fees, which is just $100. Tuition is $12,000. Books is $450. Tools and supplies is $2,400, totaling up to almost $14,990. And in the first video, I talked about how a lot of that is covered with free money, which is Pell Grants, Pell Grants are awarded to eligible undergraduate students. This is an undergraduate program, so you do get college credit, like I was saying in the first video. Those that haven't earned a bachelor's degree or graduate degree, the amount of money awarded is based upon the student's expected family contribution, EFC, to help the students with tuition costs. Okay? So that's how that works. This is an actual college. It's a private college. It's equivalent to going to a private college to learn a vocational trade. So it's weird. It's hard to explain because you learn a lot of math at a high level. I'm talking about geometry, trigonometry, stuff like that, basic shop math. And then you learn how to read and negotiate a scientific calculator. It's good stuff, man. You learn a lot of good stuff. Let me finish this manual real quick so we can go forward. So again, let's see. Once you graduate, you have 6 months. You have 6 months before you start making any kind of financial aid contributions, which mine are $90 a month or something. 92. It's nothing. And let's see. These are the instructors, which they talk about the instructors, and they break down all their accomplishments professionally, so you understand why they're qualified to teach what they teach. The mathematics here are covered. Algebra, geometry, trigonometry, shop theory, blueprint reading, computer numeric control, that's your CNC, which is why you're in this program. I also talked about the course is 905 hours. You get 51.5 quarter credit hours, which is college credit as a quarter system. I talked about that in my first video. This course is broken down into modules, training modules. Module 1, Module 2, Module 3, Module 4, Module 5. Each module is about 6 weeks in length. They're specifically designed to pick up where the other one left off. And it covers blueprints in all of them, math in all of them, machining fundamentals in all of them, and it's very exhaustive. It's very, very, very thorough, and you will learn a lot. Trust me. So, again, last time, refer to part one. So that's the curriculum. That's what I pretty much covered. The curriculum of the school for the Machinist Training Program at NTMA in Santa Fe Springs, California. All right, this is the current catalog as of between January 2020 and November 2020. Right now we're in June of 2020, so this is current. All right, now I'll put that aside. What we'll do now is we'll pick up on the textbooks that they issue. One of the things that they will issue is a blueprint reading for the machine trades. This is a very good textbook, and there's a lot of like little work, side work you can do to enhance your skills. So I plan on myself keeping this going for myself. See, like it talks about wall thickness. Wall thickness is something that is very commonly talked about in our trade. And you can see how I was filling in these things, and I got like notes and stuff written everywhere. Wall thickness is very important. These symbols are very important. Max wall, min wall. You're going to learn all this. Cast iron, spot facing, all these things. And it defines, spot facing would be defined here. And as you can see, some of it is highlighted in yellow. It's very important to study this stuff. Unit 8, sectional views, full sections and half sections. I'm not going to go over this because if you're not interested, then you don't have to listen. But if you're interested, take the course. Surface roughness, these are symbols. This is all blueprints. Very, very, very crucial stuff to learn, because blueprint reading is, you have to know it to be a machinist or work in the metal trades. You really have to know it. And you're going to constantly be inundated over and over again with this book. Okay, this book is very important. Okay, that's textbook number 1. Textbook number 2 is the new practical mathematics for metalworking trainees. Obviously, this one's from NTMA. So you're going to go over trigonometry. You're going to go over planes, geometry, geometric symbols, geometric principles, area and volume, triangles, which is trigonometry. You're going to learn a lot of math. Math that I never really studied previously to this, because this is some advanced level stuff. But it's a really thorough course. Engineering level type training. Okay, so there's your math book. That's a textbook. You will be issued that. Here is the machining fundamentals textbook. And it has some really good pictures in it. It's a good book too. They're all good books. Talks about all the different breakdowns of using a bandsaw. You will use a bandsaw at the school for sure. So get used to working with your hands, hands-on. Power bandsaw. You're going to learn how to use that bad boy. Trust me when I tell you, you will cut metal. You're going to be cutting pipe. This picture right here, you're going to do it. If you take this course, you will cut metal. You will cut aluminum. You will cut steel. Those are two of the basic metals that you're going to use at the school, is steel and aluminum. And so that's kind of nice, because a lot of schools don't get a chance to use two different kinds of metals like that. So it's a very good program in that way. You're going to learn how to set up jigs and fixtures. I'm not going to go into that because you'll learn if you go, but you can read it in the textbook what a jig and fixture is. This book is very well done. So here's one of the things I wanted to cover is some of the tools that you're going to have to learn, some of the hand tools that you're going to have to be familiar with. And in this particular case, it's going to be a 0 to 1 OD mic. Okay, and as you see in this picture, this picture depicts a man holding, a machinist properly holding a 0 to 1 OD mic as he's measuring whatever he's measuring there, to make sure he's measuring the outside diameter of whatever it is. And that's what a 0 to 1 OD mic does. It measures the outside diameter of a particular piece of metal or plastic or whatever material you're using. And as you see here, whatever material that is, whether it's steel or aluminum, looks like aluminum, he's measuring the outside diameter of that particular piece of material. And he's properly holding it, and he's adjusting it here, and he's holding that tool in his hands properly. So let me talk about that particular tool right now. Here is one of my OD mics. This is a kind of somewhat expensive one. It is a Mitutoyo 0 to 1 as you see, there's 4 decimal places. There's the 0.000 and then 1. So it's a 4 decimal place, 0 to 1 OD mic, and this one is a digital caliper. So you see digital readout. You can see right there, it's reading 620 thousandths of an inch. This locks it down, so I can unlock that. And here's your deal right here. See how it says 0, 1, 2, 3, 4, 5, 6. That's your 6 for the 620. And then you go to the vernier scale, which is here on the side. I'm trying to get this thing to focus. So you see the 20 right there, and then you see over here there's a 0. Okay, let's see if we can do it better. There, you see the 0? And there's your 20. 620, right? There. $621. See the 21? See the 621? 622. See the 22? 0. 6. 22. See the 6, 20, 22. Hopefully that makes sense. Then you go up to 623, 24. Now 0, what do you think, right? 0. If I can get the focus. Try to get this thing to focus. There, 0 and 0, right? So from 24, where do you go to 25, right? So 6, 20, see the 5? See how that moves? What is this going to be? See the 1? Line it up with the 0? What is that? After 25 is 620. It's 7, so that must mean it's a 2. Which 626 would be the 1. Right. Keep going to get to that 5, which would be here 0. What do you think that is? 630. And then let's go to 6. What do you think that is? 631. Let's go to 7. Along that 0. 632. Let's go to 8. Line it up with that 0. 633. You starting to see? And then 634, 35, 39, and then the 10 will be 640, right? Or I'm sorry, 635, and then all the way to 40. Keep going, 5 more. So that 15 with that 0, 640. You see how that works? That's how you measure. What that is 600, in this case, let's go to 640 thousandths. See how it's lined up with that 15 and the 0? 640 thousandths of an inch. This little space right here, from the anvil to this top right here. That's 640 thousandths of an inch. Okay, now when you're in the class, in the school, I just gave you a really quick overview. You're going to go over all this stuff on how to read the outside diameter as well as the inside diameter of a particular piece of material You're gonna study so much. Like, I mean, I have like this, outside micrometer, OD mic. I have one like that too. This is a Starrett. It's a little different. It's more of a old school versus that digital one like that. You see the two of them together. They're both 0 to 1 OD mics. This one is digital, and this one is more manual. It's the same thing. Same basic concept. Just one is digital read. It's a little easier to kind of turn that thing. And you're going to go over all these different tools, man. There's a ton of tools. This is inspection stuff. Okay, like these right here. These are called dial calipers. Okay, now I got a set of dial calipers right here. And you're going to get very, very familiar with using these. Same thing. Measurements: 100,000, 200 thousandths of an inch, 300 thousandths of an inch, 400 thousandths of an inch. Okay, well, let's go right. 400,000, 405, 410,000, 415,000, 420,000, 425, 430. That would be 430 thousandths of an inch. 500 thousandths, you're going all the way up here to the 0. See the 0? And then right here, that's half an inch. 500 thousandths is half an inch. Which would mean what? As you go all the way to 750, 750 thousandths, that's 3/4 of an inch. So the distance between there and there is 3/4 of an inch. You want to go to a full inch? What do you think that is? There it is. Make sure that 0 lines up. Like that. Now you're at exactly 1 inch. Which, when you open these up, the 0 to 1 OD mics, they go 0 to 1 inch maximum. This one here can go further. It can go, 4, 5, 6 inches. This is a 6-inch caliper, so it just keeps opening. See how it keeps opening? See that? Six inches. It's hard to get this thing to focus, but bottom line, 6 inches, 0 to 1 inch. So a couple of tools right there, and then you're gonna always wear your safety glasses. That's a must. Every day you're in class. When you're in the shop, safety glasses. Now, when you're in the classroom, you don't have to wear these, but in the shop, yes, sir, you will be wearing those. Okay, this is just to cover some of the things I made. This one was a really simple piece of aluminum, which was machined out on a CNC lathe and a mill. We used both. This was machined out on the lathe. See how it's got like different, it's called a step threaded, it's a project just to show you how to do step threading. These are all threaded. A lot of fun. And then we made this cool little machinist hammer. We knurled the backhand there on a lathe, a manual, conventional lathe. Then we did a taper. You see how it tapers? And then we got this little head here, and then we had to put this piece of nylon and mill out the inside of this. It was a lot of fun. So this is one of the projects you're going to do at the school. Another project. There's others. I just brought out 3 of them. And all this stuff is covered in the Machinist Fundamentals. Teaches you how to read a steel rule. And it's very, very thorough, very, very detailed. Some more blueprint stuff. It shows you how the machinist industry is so in everywhere. That's the Osprey, like Marines use that to fly their troops into battle and stuff like that. There's just a lot of different things for the machinist trade that You're going to learn Blue Angels. You're going to learn how to do, like, here's some safety stuff, how to dispose of rags, and you're going to learn a lot of stuff. See, shop safety, it's a big part of it. Different mills and lathes you're going to operate. The school uses the brand known as Haas, which is Haas, Haas, and they provide the CNC mills and CNC lathes that the school uses that they will teach you about. You're going to learn about twist drills, reaming on a lathe, amazing stuff, really amazing stuff. It's really hard to go over just a quick video, but you're going to learn about grinding operations, just a ton of things, man. Again, jigs and fixtures, fasteners, how to program stuff. You're going to learn how to inspect things, how to finish, metal finishing, and these are all special skills that you're going to learn, and then you're going to get really good at some of these things, better at certain things than you are at others. So you could specialize. So being a machinist is amazing. It's an amazing field. And again, this is part 2. So I just wanted to go over in part 2 the textbooks, which you just saw, the math, the blueprint, and the machinist fundamentals textbooks. And I wanted to go over a couple of the projects that we did in the school, and some of the tools that you will get familiar with that are like tools of the trade. And there you go.